All right, welcome back to another video. While the dictionary project is uploading, I'm going to go ahead and do another one. So this one I think is a really good way to learn some simple concepts, and it's a very simple problem to approach because I'm going to walk you through actually how to conquer kind of a starting point and then develop the code after that. So one of my favorite problems is actually writing the Fibonacci sequence in code. So today we're going to cover functions and making things repeatable, and we're also going to look at some parameters inside of those functions, and then some math, because I feel like without math you really can't code anything. As you guys have seen in the other videos, there's a lot of numbers involved in scripting. No matter kind of what stage. I mean, it could be very rudimentary math from 0 plus 1 to very complex problems like n times 3 plus 1. Um, and if you don't know anything about that, then just ignore that I said it before you get lost in a rabbit hole. So we're going to do the Fibonacci sequence. So let me pull up kind of, I'm sure you've heard of it or seen it somewhere in a movie or literature or a TV show. It's very common. So I'm going to pull up this window so we can look at that really quick. All right. So the Fibonacci sequence is F0 starts at 0 and F1 starts at 1. So these are just the number placements. So this is N0, the 0th position, and N1 in the first position or second position. So it's just saying that our number equals Fn1 plus Fn2 equals the next number in sequence. So the sequence starts 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and just so forth. So our sum from the last two numbers plus the second number. So again, the sum of 0 and 1 is 1. So now we're going to do 1 plus our sum, the second number plus whatever number we got equals the next number in the sequence. So then 1 was our result for 1 plus or for 0 plus 1. 1 plus 1 equals 2. So now we have this. So this second number becomes our first number, and then our second number is the sum. So 1 plus 2 equals 3, and so forth. And we can come down here a little bit, and we can find this table that has all the way up to what the 20th position is going to be, 6,765. So this is really simple on paper. How to code it though? There's the trick. So let me just lay out some simple things here. Let's put in this. So the Fibonacci sequence equals A plus B equals C, and then B plus C equals D, and C plus D equals E, and so forth until you come to an end, or if you don't. The logic is Fn equals Fn minus 1, so whatever our last number was, plus Fn minus 2. So our sum is of the last two numbers in the sequence, right? So easy enough. Nothing really to it. I just explained it in easier terms than Fn minus 1 and Fn minus 2 because Fn is our last point. So from Wikipedia, let me copy this really quick. The Fibonacci sequence is such that each number is the sum of the two preceding ones, starting from 0 and 1. In some older books, the value of F0 is omitted, so that sequence starts with Fn equals F2 equals 1. So both numbers are 1 at the start, which is easy enough. Let's just start at 1. There's no reason to include 0. And the sequence for verification is that table that I showed you guys, which ends at 6,765. Perfect. So let's get started on this. So the first thing I want to do is, I guess, figure out the math, and then let's wrap it in a function. So first thing we need to do is, we know we have these two numbers, right? So what our current number is, what our previous number was, um, and then you know, what our endpoint is going to be, what our I guess last one is going to be. So Fn is these two added together. So let's just start with um, something that might not make sense at first, but we know that Fn and F2 both start with equal to 1. So let's call current is equal to previous is equal to 1. So what this looks like is current and previous are both equal to 1, which is a good starting point. So now let's just say while true. That'll run indefinitely, not a big deal. We're going to say that our current number is what we want to see. So that might seem weird, but I don't want to keep declaring a ton of variables, because clearly we can keep reusing these numbers that are popping up, because they're either the first number in the sequence, the second number in the sequence, or they're the sum, and we're going to always use the second number in the sequence in the next part of the sequence, so we don't want to get rid of that. And we always want to keep the sum, and we need the starting point because we need to know what we're adding every time. So I know that seems a little complicated, but once I show you guys this math, it's going to be very simple. So our equation is always going to look like this: current plus previous, right? So now we've got 2. And so what we want to do is save this 2 to our current first number. And then we're going to save, I'll show you guys here in a second, or sorry, to our second number. So what we need to do is current and previous. Let's just keep overriding them. It's the easiest thing to do. Current plus previous, and then current. So what that looks like is current is now 2 and previous is 1. So current is actually Fn2 and previous is Fn1. So I guess I could have maybe named the variables differently, but if I name them current, I know that it's the current sum or iteration. So current is actually 1 plus 1 equals 2, and previous is the last number in the sequence. So if I copy this and run this right here, I'm going to run this and I'm going to stop it pretty quick because it's going to get out of control. Oh my gosh, yeah, see, there we go. No, cancel, cancel, cancel. Actually, I'm going to do this. While current less than 7,000. Rerun this. Oh, I should probably remove variable current, move variable previous. Now rerun this. Oh, well, I'm not adding anything.